Hi class, welcome to Math 2015 Learning Outcome 14 video. We're going to use bar models to solve word problems involving variables and produce an answer statement involving an algebraic expression. So up until now, our bar models have had numbers throughout all of the problem. Then in Learning Outcome 11 and 12. Then in Learning Outcome 13, we added a variable to help us solve a numerical answer for the word problem. Now we're going to go to one more level of abstraction and have variables throughout, variables in the problems and variables in the answer, so that we have an algebraic expression as the answer. Okay, so we're going to do this through a series of examples. First, we need to produce a bar model and teacher solution for the following situation. The total number of pupils in Class A and Class B is J. There are 4 more pupils in Class A than in Class B. How many students are in Class B? So here we can see that the J is our variable. We normally have a number there, but we don't know what the number is, so we put a letter there. Okay, let's go ahead and make a bar model. So we're talking about pupils in Class A and B. So let's make a bar for Class A and a bar for Class B. We know that there's 4 more pupils in Class A than Class B. So we'll take this bar and we'll add on another one and put 4 there. Class B is the same as Class A, but up until the 4 only. Okay. So here's our Class B bar. Here's our Class A bar. Now what we need to do is we need to find out how many students are in Class B. Well, we have a couple of other pieces of information. We know that all of the students together are J, so we'll put a brace here and put J. And we need to put our question mark on. We know that we want to know how many are in Class B. So our arithmetic will involve just variables. Like Learning Outcome 13, we need to find a variable, say x, and apply it to our situation. We need to say what x will mean. Let x equal we can go for what we want in this case. So let's x equal the number of student pupils in Class B. Let equal the number of pupils in Class B. That's what we want. Now, we can assign it to what we want, and let's see if we can make an equation between the total number and Class A, which gives us a clue of 4, and our x's. So if we can form an equation with Class B as x, then we go with that. Otherwise, we might have to rethink what we want x to be, or our variable. So I put x to be number of pupils in Class B. We know that the total number of pupils is J. The total number, so we're going to put x here. The Class A and B have the same amount except for x, but then there's 4 more in Class A. So we have x, which is the number of pupils in Class B, added to x plus 4, which is the number of pupils in Class A. So I put those in parentheses. All of that is equal to J. Now normally J is a number, but we don't have a number there. We don't know how many there is, but we can still say something about it. Now x is the number of pupils in Class B, so if we solve for x with this equation, we can find the answer, or as much of it as we can possibly with certain unknowns. So we have 2x plus 4 is equal to j. Subtracting 4 from both sides, we get 2x is equal to j minus 4. J subtract 4. Okay. Dividing by 2, x is going to be j minus 4 over 2. Okay. Now notice that in our learning outcome it said that our answers will be expressions. So that's as much as I can say about the number of pupils in Class B. You take the total number of students, subtract 4, divide by 2. And that's kind of what we're going to do here in our answer. There are j minus 4 over 2 pupils in Class B. Okay, period. Now, this is a model for the homework. We have our bar model with question mark. Check. We have our x equal to an expression, or part x equal to a part of our story problem, some aspect of it there, so that's labeled specifically, and we have our arithmetic, so 4 points. Oh, and our answer in a sentence, so 4 points here for the problem. Okay. Let's move on to the next one. Try another example. 4/9 of the students in the class had chickenpox at the same time. If P students had never had chickenpox, how many students were in the class? Okay, so what we're doing is we're going to pretend that P is a number, but we're going to do all of our operations as if P was a number, but we just put a P in for the number. So if 4/9 of the students had the chickenpox in the class, and P students had never had chickenpox, we're going to have a bar that has 9/9, 4 for the number of ones who had chickenpox, and then the rest for the ones who don't. Okay, so we're going to have a bar, so our class, you can label that if we want to, but we need 4/9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so here's the 9ths in my bar. Okay, now 4 of them had chickenpox at the same time, so I'm going to find 4 here. Okay, there's 4. 4/9 had chickenpox. Okay. 5/9 of the class did not. Okay, so I'm going to do some coloring here for 4/9. Okay. Now, 5/9 did not, but it said in the problem above here, P students never had them. Okay, so we also want to include P, or P students did not. Okay. All right. Now we know that we want a relationship to the fraction because we want to know how many students are in class, or we want to know the entire 9/9, or the whole part. So we say that P is equal to 5/9 of the class. Okay, so we want to we want to say what P is. So let P equal the number of students without chickenpox. Okay. Now P is equal to 5/9 of the class. We want to know how many students are in the whole class, but P is going to be a variable, so we don't know what that is. What we want to do then is manipulate the equation on both sides to get 9/9, the entire class. Okay. So we're going to do a breakdown and a build-up. We'll break down the 5/9 into 1/9, and then we'll build that 1/9 up to 9/9. Okay, so if I want to break down to 1/9, P is going to be equal to 1/9, some version of P, I divided by 5. So from here to here, I divide by 5. Because my numerator went from 5 to 1. But what does that do for my P? We'll have to also divide by 5. And then put P over 5. Now normally we have a number there, and it would just be some number again. But since we don't, we're just going to kind of build up an expression. Now we want to get, again, to the whole class, and so we got to get 9/9 here. So to get from 1/9 to 9/9, I multiply by 9. And so I'm going to multiply by 9 as well over here. So we have 9P over 5. Okay. So that's 9/9 of the class, or the whole class. So we'll do 9/5 P equals whole class. Okay, and so that's what we're going to do in our sentence. To answer the question, how many students were there in the class? there were 9/5 P students in the class. Okay, let's take a look and see if we did everything. So does my bar model have a question mark? I did a bar model, but I didn't do the question mark. We want to know how many students were in the class. So that's going to be the whole thing here. Put a question mark up there. Now, my bar model does have its question mark. All the parts are labeled. So let's check. I've labeled my variable as some number of something related to the problem. So let's check. Arithmetic, check. Answer in a sentence, check. Okay, so this looks like a good problem. Here's another one. 3 people started a business with a capital of $Z. Capital is your initial amount that you need, and you start your business. Buy the rent space, buy some product, buy computers, and sell things. Okay, that's the capital. If their shares in the business are in a ratio of 3 to 5 to 7, how much did each contribute to the startup of the business? How much did each contribute to the capital? Okay, so we have a ratio here, and we usually display each of those ratios as a bar. So each person has 3 to 5 to 7 ratio. So there are going to be 3 units for one person, 5 units for another, 7 units for another. And the whole thing together is $Z. Normally, Z will be a number, but we can work with it and have an expression in our answer for how much each contributed. Now this will have 3 answers because the question is asking for how much did each person contribute. It's going to be some form of Z. Well, let's take a look at person A, B, and C. Their bars. So person A contributed 3 units. Person B contributed 5 units. So it's the same as the 3 units plus 2 more. And person C contributed 7 units. Okay, so it's the same as the 5 units. Draw those in there evenly. And plus 2 more. Okay. Person A, B, and C. Now, we know that everything that they contributed was $Z, so we're going to put a big brace here and put our $Z here. Okay. Now, when we solve these ratio problems or anything in the bar models, we want to try to get a unit solution. So one piece. Okay, so we're going to let X be that piece. Once we find out what 1 unit is, we're going to say, okay, person A did 3 of those units, person B did 5, and person C did 7. Okay, so we're going to do let X be 1 unit of business capital. Okay. Now, how many total business capitals there are? There's $Z of it, but how many units? So, or X. How many X's? 1, 2, 3. So we can count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's 15 units in all. So 15X is going to equal the $Z. Okay, normally we know how much that is, but we're going to just work with it. That means that X, each unit X is going to be Z over $15. Okay. Now, once we know that the unit is Z over $15, we're going to say, in the end, our sentences. Person A contributed 3 X's, or 3 units, which is equal to 3 times the quantity Z over $15, which is equal to, so the 3 and the 15 can simplify to 1/5. Okay, so to 1/5 $Z. Okay. Person B contributed 5X. So that's 5 times z over $15, which is equal to the 5 and the 15 will cancel, so we have 1/3 z dollars. And then person C contributed 7x, 7 units, or 7 times z over 15, which is equal to 7/15 z dollars. Okay, so that's my answers in the sentence. Okay, so we have our question mark. Ooh, what's your question mark? How much did each contribute? Okay, so we have to put question marks here. Question mark there. Question mark there. Question mark there. Okay, that's how much each one contributed. And so that means everything is there for my bar model. Question mark. Letting x be something, some part of the aspect of the problem, the arithmetic, and each answer in the sentence. Okay, so 4 points looks good. Okay, let's try a couple of homework examples. All right, class, in this video, we're going to go over a couple of homework problems from Learning Outcome 14 to get you a jump start on there. Learning Outcome 14 has starts as problem 35 for the unit, and we'll do B and C. So here's B. The problem states a concert hall has seats for an audience of S people. How many people are in the hall when 4/9 of the hall is filled? Okay, so we have concert hall and seats. Okay, so we have all of them first. Just 4/9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the concert hall will have 9 nights divided into nights. Okay, and all of them together makes S seats. Okay. Normally that will be a number, but it's a variable, so we'll work with that. How many people are in the hall when 4/9 are filled? So we do filling up 4/9 here. 1, 2, 3, 4. So we have 4/9. Okay, so S seats means the number of people as well. S people. Okay. So all of them together look like have 9 units. Okay. Let S equal the number of people in the concert hall. Okay. No, that's S is all of them, or 9/9 of them. So what we need to do is we need to get it down to 4/9. Okay. So S people is equal to 9/9 of the concert hall. Okay. Now, when 4/9 are filled, then how many people is that? We need to break our 9/9 down into 4/9. So in order to do that, we have to go from 9/9 down to 1/9, break down to 1/9 to the unit fraction, then build up to 4/9. Okay. So if we want to go down to 1/9, we're going to divide by 9. So if we divide by 9 over here, we'll get S over 9 people. Okay, now we need to build this 9/9 up to 4/9. Okay, so we want 4/9 of hall. Okay, so that would be multiplied by 4. And so we have 4S over 9 people. Looks like there's a direct correlation here between the seats and the people, which makes sense, right? So we're going to say that, so when 4/9 of the hall is filled, the 4/9 of people, so there's 4/9 S seats filled in the hall. And there's 4/9 people. Okay, so we want to know how many this is right here. Question mark. Bar model with a question mark. Check. Add variable identified and explained. Check. Arithmetic. Check. And answer in a complete sentence. Check. Okay, so I have a good homework problem here. Okay, next one. Learning outcome 14, number 35C. Okay, in this video in this problem we have the enrollment at a school was Y students last year and increased 20% this year. Okay. Enrollment Y students last year increase 20% this year. Okay. How many was it this year? Okay, so this is a percent, so we're going to draw a bar model for each of these. So last year and this year. So we have last year's enrollment and this year's enrollment. Okay, percent. Okay, so this is 0%. 100%. Okay, last year's enrollment was 100%. And we also know that that's Y students. Now, we want to know if this year's enrollment is going to be 80% or 120%. So there is 20% more this year than last year. So we have to interpret this a little bit. Whatever comes after than is the whole, or the 100%. Okay, so this year's enrollment is going to be more the crazy bar. Okay, this bar will just be filled in. Long bar. Okay, 120%. Okay, so this year's enrollment is 20% more than last year's enrollment, right? And we know that last year's enrollment is related to Y students. So we want to know how many students are for this year, so we're going to put our question mark here. And we're going to make a relation for arithmetic. The number of students last year was 100% and 100% in Y. So we have 100% corresponds with Y students. Now, all we know is that the increase became 20%. So if we find out how much students 120% is, we'll break down our 100% and build up to 120. So I recommend a breakdown to 10% and then build up to 120 from there. Now, from 100% to 10%, we divide by 10. Y students divided by 10 is going to be Y over 10 students. Okay, we don't know how many there are, but we can still keep the variable there and put all the arithmetic in as an expression. So 120% is what we want. That is times 12. And then this one times 12 is going to be 12Y over 10. So I multiply my 12 and then numerator. Students. Okay, so we have our arithmetic, our answer, our bar model, let's go ahead and write it as a sentence. There are 12 over 10y. That I just caught that, and that's probably a fraction that can be simplified. Let's do 6 over 5y. Simplified. So there's 6 over 5y students enrolled this year. Period. Okay, so let's check our work. Bar model with question mark. Check. Variable. Let we don't have a variable here identified. We have y students. So we're going to say let y equal number of students enrolled last year. Okay, so variable identified and related to our problem. Arithmetic, check. And answer in a complete sentence, check. So now we've got it, all of our parts for our homework problem. Please let me know if you have any questions.